Now that we have calculated the values of the components, we need to list our rules to start to solve this question. And the rules that we have so far is the resultant being downwards. That means that the x component for the resultant is 0, and the y component of the resultant is same as the resultant itself. So that means that the sum of all forces in x direction is equal to Rx, and Rx happens to be 0. So the conclusion is sum of all forces in x direction is equal to 0. That is rule number 1. And the sum of all forces in y direction is equal to Ry. In this case, Ry itself is R, so it's equal to R. So the conclusion is sum of all forces in y direction is equal to R, and this is the second rule. So these are the two rules that we have so far, and we need to follow these in our calculation. But it is important that we notice for the sum of all forces in y direction is equal to R, this is in equation number 2, is equal to the value of the resultant. But the value of the resultant also follows the rules of forces. The rules of forces, if we remember from previous classes, that when it is in this direction it is positive, and when it is upwards it is positive, but it is in this direction then negative, and if it is downward it is also negative. These are the rules that we set up for forces, and this applies to the resultant also. So in this case we need to make sure that when we say sum of all forces in y direction equal to R, it is equal not to 45, it is equal to minus 45. So if you make it equal to 45, as if you are saying that the resultant direction is this, and that is not true. So you have to make sure that we don't make a mistake of like that. Now once we got this, we can start with either or. So the question here after that is, shall we start with the all forces in x direction equal to 0, or all forces in y direction equal to 0? Both of them actually in this case will have the very same result, because the equation of all forces in x direction will involve two elements that are unknown. In this case it will involve this element and this element. They have F2 and F3, both of them are unknown. And if we do all forces in y direction equal to 0 to R, sorry, minus 45, then we have this element is unknown and this element is unknown. It has F2 and F3 in both of them. So that's why again, like I said, you can start with either or. So we can do all forces in y direction equal to R. In that case we start from the F1y, which is this one. So F1y will be equal to minus 17.8, and F2y again is minus 0.927 F2, and the F3 component is equal to minus 0.6. F3 is equal to minus 45. With this equation we'll have two unknowns. This is unknown and this is unknown, and if we try the sum of all forces in x direction equal to 0, again we have minus 12.93 for F1x, and we have plus 0.374 for F2, and we have plus 0.8 F3 is equal to 0. So again, if we take a closer look to the equation of x, is you have this is unknown and this is unknown. This is F2. In this part I will just go through the calculation based on the two concepts that we set for ourselves to solve this problem, and that is, first is we said the sum of all forces in y direction are equal to the resultant itself, and the other thing is that we have the sum of all forces in the x direction equal to 0. So for the first one, we said we have to pay attention to the issue of this minus 45, and if you look at the equation, the y components for all of these forces, be it 17, this is downwards, and this is downwards, and this is downwards, so all are negative. So that's why, see, at the end we'll have an equation that has negatives all over them. So to solve this problem, we will just multiply both sides by negative, then becomes all of them become positive. I continue the solution because I have two unknowns, this one and this one, so we have to isolate one of them in terms of the other. So we come up with the equation number 3. Then we move to sum of all forces in the x direction equal to 0. And in this case again it is straightforward. We have this element negative, and the other two elements, this one and this one, are positive. As you can see in the equation, this is negative, positive, positive, and then we will substitute for the value of f2 in equation number 3 as it is mentioned here. So at the end, the detailed calculation is in your document. You can take a look at that one if you want to. So f3 will be equal to this much, and then use this value in this equation, and you get the value like so, and you get the value of this one.